fluorocarbon fibers. It is a very special yarns. The high performance fibers are produced from the fluorocarbon fibers. It is a very special fibers. Introduction of fluorocarbon fibers. Nanotechnology has real commercial potential for the textile industry. This is mainly due to the fact that conventional methods used to impart different properties to fabrics often do not lead to permanent effects and will lose their functions after laundering or wearing. So, nanotechnology as a real commercial means it is a conventional methods used by spinning properties like mold spinning, composite spinning, and very after functioning effects to permanent effects in laundering and wearings. So, nanotechnology can provide high durability for fabrics because nanoparticles have a large surface area to volume ratio and high surface energy, thus presenting better affinity for fabrics and leading to an increase in durability of the function. In addition, a coating of nanoparticles on fabrics will not affect their breathability or hand feel. Therefore, the interest in using nanotechnologies in the textile industry is increasing. They provide only durable nanoparticles, very high volume energies like hospitalities and surgical operations like sutures of different types of threads used in the medical fields. What is fluorocarbon? The fluorocarbons are chemical compounds that contains carbon fluorobonds. The relatively low reactivity and high porosity of the carbon fluorine bond imparts unique characteristics to fluorocarbons. Fluorocarbons tends to be only slow broken down in the environment and therefore many are considered persistent organic pollutants. Many commercially useful fluorocarbons are may be considered persistent organic pollutants. Many commercially useful fluorocarbons also contain hydrogen, fluorine, or bromine stain and water repellency. The critical surface tension of a solid fabric is greater than or equal to the surface tension of a liquid. The liquid will wet the fabric if the critical surface tension of the solid is less than the surface tension of the liquid. The fabric will repel the liquid. So, fluorocarbons are chemical compounds that contains carbon fluorobonds, which bonding of the characteristics is very high plurality and it will be very slowly broken down with the environment else because it contains hydrogen, fluorine, and bromine and stain and water repellency. Water repellency is known as the fabric is repellency. The surface tension is where liquid will not be affected for the fabric. And PTFE, polytetrafluoroethylene, offers very extremely high chemical resistance of fibers. Because polytetrafluoroethylenes have high compound of hydrogen oxides and hydrodensity polyethylenes of good thermal stabilities. It also has an extremely low coefficient of friction, which can either have advantages or disadvantages depending on the use of low coefficient of friction. High density polypropylene can be extruded using special technology to produce very high molecular orientation. The resulting of fibers combines high strength, high chemical resistance, and good wear properties with lightweight, making it highly desirable for applications ranging from cut-proof protective gear to marine ropes. Since it is higher than lighter than water ropes made up of high density polyethylene float, its primary drawback is its low softening and melting temperature. Different types of fluorocarbon finishers of the fabric. In the case of solids, critical surface tension is used instead of surface tension. Thus, water repellency can be obtained when the critical surface tension of the solid is smaller than surface tension of the liquid. For example, when a drop of water is dripped on a cotton fabric, it has been experimentally determined that the surface tension of the water and the critical surface tension of cotton are respectively 72 dynes per centimeters and 200 dynes per centimeters, and therefore water readily wets the cotton fiber. However, once the cotton is treated with fluorocarbon, the hydro-repellent relation between them changes. The critical surface tension of water repellent finished cotton is less than the surface tension of water. Fluorocarbons are organic compounds consisting fluorinated carbon chain that tends to decrease the surface tension of the substrate. The fluorocarbons generally lower the surface tensions by forming a thin film of coating around the fiber. They usually are cationic in nature but can also non-ionic and anionic. Some useful fluorocarbons are ferroxyl acetate copolymers and their fundamental structure resembles that of acrylic resins. The surface tension of the fluorocarbon water repellent agent is extremely small, about 10 dyne per centimeter. Therefore, water repellency can be obtained by water drop does not adhere on the treated cotton fiber. Industry started using water repellents based on paraffin, silicon, and fluorocarbons. Comparing three systems, it has found that those belonging to the paraffin type have low water repellent effect of initial stage and no durability to washing. Those of silicon type were better than the paraffin based products but were poor oil repellents. The fluorocarbon based products were found to endo excellent oil water repellency. Cross-links agents are invisible for improving the durability of fluorocarbon water repellent agents. They prevent the water repellent agents from dropping out of the fibers on washing because they form a three-dimensional network and attach the water repellent agent to the fiber. Generally, when adhering material to the surface of material, the more physical properties of two materials are similar, the more strongly they adhere to each other. Generally, hydrophobic fluorocarbons strongly adhere to synthetic fibers which also are strong hydrophobic. Thank you. ఇది ఎట్లా చిన్నది